Welcome to our comprehensive guide on configuration management in Go. Configuration management is a crucial aspect of building robust and maintainable applications. It involves handling application settings, environment variables, configuration files, and implementing best practices to ensure your Go applications can adapt to different environments seamlessly. Throughout this tutorial, we'll explore how to effectively manage environment variables, work with various configuration file formats, and implement industry-standard best practices that will make your applications more flexible and secure. Let's start with the most basic form of configuration management: reading environment variables. Go provides the OS package with the getEnd function to access environment variables. The first example shows how to read a port environment variable using os.getEnd. If the environment variable exists, it returns its value as a string. If it doesn't exist, it returns an empty string. The second example demonstrates a more robust approach by creating a helper function called getEnd that accepts a key and a default value. This function checks if the environment variable exists and has a non-empty value. If it does, it returns that value. Otherwise, it returns the provided default value. This pattern is extremely useful because it ensures your application has sensible defaults even when environment variables are not set. Environment variables are always returned as strings, but often we need them as different data types like integers or booleans. Here we see how to handle type conversions safely. The getEnd as int function demonstrates converting environment variables to integers. It first retrieves the environment variable as a string, then uses the strengthfind.atoy function to convert it to an integer. If the conversion is successful and no error occurs, it returns the converted integer value. If conversion fails, it returns the provided default value. This approach prevents your application from crashing due to invalid environment variable values and ensures type safety throughout your application. While environment variables are great for simple configurations, complex applications often require structured configuration files. The two most popular formats are JSON and YAML. JSON configuration uses a hierarchical structure with curly braces and key-value pairs. In our example, we have a database section with host, port, and username fields, and a server section with port and timeout settings. YAML configuration provides the same information, but with a more human-readable format, using indentation instead of brackets. YAML is often preferred for its cleaner syntax and better readability, especially for complex nested configurations. Both formats support the same data types and can represent complex configuration structures effectively. To read JSON configuration files in Go, we need to define a struct that matches our configuration structure. Each field in the struct uses JSON tags to map to the corresponding keys in the configuration file. The config struct defines a database field, which itself is a struct containing host, port, and username fields. Each field has a JSON tag that specifies the corresponding key in the JSON file. To load the configuration, we use os.readFile to read the configuration file into a byte slice, create an instance of our config struct, and then use json.unmarshal to parse the JSON data into our struct. This approach provides type safety and makes it easy to access configuration values throughout your application using dot notation. For more advanced configuration management, the Viper library is the most popular choice in the Go ecosystem. Viper provides a complete configuration solution that supports multiple file formats, environment variables, and remote configuration systems. The loadConfig function demonstrates basic Viper usage. First, we set the configuration file name using setConfigName. Then, addConfigPath tells Viper where to look for the configuration file. The automatic end function enables automatic reading of environment variables. When we call readInConfig, Viper automatically detects the file format and loads the configuration. Finally, we can access configuration values using getString and other getter methods with dot notation for nested values. Viper automatically handles the precedence between configuration files and environment variables, making it extremely powerful for production applications. Following best practices is essential for maintaining secure and reliable applications. First, secure your secrets by never committing sensitive information like passwords, API keys, or tokens to version control. Always use environment variables or dedicated secret management systems for sensitive data. Second, provide sensible default values for all configuration parameters. This ensures your application can start and run even in minimal environments, making deployment and testing much smoother. Third, implement configuration validation on application startup. Validate that required fields are present, numeric values are within acceptable ranges, and URLs are properly formatted. Catching configuration errors early prevents runtime failures and makes debugging much easier. Finally, document all configuration options thoroughly. Include examples, describe expected value ranges, and explain the purpose of each setting. Good documentation helps team members understand and maintain the application configuration effectively. Let's look at a complete configuration structure that brings together all the concepts we've discussed. The app_config struct serves as the root configuration object and contains nested structures for different application components. It includes server config for server-related settings, database config for database connections, and Redis config for Redis cache configuration. Each nested struct uses YAML tags for clean configuration file mapping. The load config function represents a typical configuration loading pattern where we create a new app_config instance and populate it from both configuration files and environment variables. This structure promotes separation of concerns by organizing related configuration options together, making the configuration easier to understand and maintain. This approach scales well as your application grows and requires additional configuration options.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.